Are you with us, Betty? There we go. Excellent. Well, thanks everybody for being here. I like to start with the opportunity for anybody that hasn't been with us before, if they want to do an introduction, or if they have and want to talk about what they've been up to or things that are going on. This is a great opportunity to do so. But I won't put anybody on the spot to tell about what I'm up to. Tom and I were just chatting about being at the Electric Aircraft Symposium, which is coming up next weekend at the in Oshkosh, just the weekend immediately prior to the AirVenture event, which pulls in about 600,000 people. So Tom and I are both going to be moderating some panels at the Electric Aircraft Symposium. That's a lot of fun. I've done that for the past couple of years. Tom, I think, has been doing it for even longer. And if you are thinking about going to Oshkosh, it's a great excuse. If you're not going to be there, but you're interested, you can also attend remotely. And I'll drop some notes into the chat. And you can also go to the Vertical Flight Society website about just to look into either attending in person or getting a link to jump in remotely. But that's a great event. We've got some great speakers. Tom, anything to add on that?
Well, and if you are going and you have gone before, note that we're at a new location on campus. So don't go to the Culver Family Welcome Center. Go to the Student Center because that's where it is this year.
That's right. That's right. Thank you. Yeah. I'm glad you brought that. I would have wandered into the wrong building myself.
I
I'm
keep
just
telling
kind of used to it.
Ken we need to advertise that a little bit more strongly, and I haven't.
Yeah.
It's a byline. Uh,
Yeah.
yeah.
Yeah. No, that's a good point. That'll be good. What else do people need to know about that event, Tom?
Uh, you know, 2 days full speakers and sessions. If you either are in the electric aircraft space or are looking to learn about what's happening, both pure electric, hybrid, some hydrogen, it kind of covers the gamut of electrification of aircraft, how multiple propulsors, uh, takeoff and landing. Rex will be there talking about all that infrastructure stuff. So it's a great way of getting yourself immersed in what's happening in the electric aircraft world right now, who the players are, and even some of who the winners and losers are. Sergio Cicada is going to be there, giving his quarterly update on what the state of the industry. So lots of great content that's happening at the symposium.
Yeah, perfect. So my panel, I've got CTOL, eSTOL, and regional air mobility. So I've got a nice mix. And you're working on propulsion, is that right, Tom?
Correct. I have the hybrid electric propulsion providers. I think Red, Vertigo, and I think Volt Arrow, but
Hydroplane?
maybe it's hydroplane. Maybe it's Anita. Yes.
Yeah,
Yeah,
Dr. Anita. Yeah,
covering the hydrogen piece of it. Yes. So
she's
yep,
great. Her work is
she is.
amazing.
Yep.
That's good. You got an awesome panel. That's going to be a solid event. Good. Well, I'm really looking forward to it already. And then I'm going to stick around for AirVenture for Monday and just kind of go do some meet and greets around the show before I head out Monday night.
Beta is flying on Tuesday, I think. So the
Ooh,
Beta CTOL, they flew at Paris, and I think they're going to be flying there. I'm not sure if the Volt Aero aircraft is going to fly. That's the hybrid electric aircraft. It will be on display, but I'm not sure if they're flying or not. But I know Beta is flying on. I'm pretty sure it's on Tuesday.
outstanding. That's right. We've got it's Dr. Body with Volt, the CEO. He's going to
Correct.
be with us on looks like Sunday at the symposium. Have they been flying?
They have been. They were flying every day at Paris.
Wow.
Yeah.
Wow, that's exciting. I like their design a lot.
And they have they're announcing their new hybrid electric engine for home builds it's already been announced, but it's going to be kind of an official rollout at AirVenture.
Very cool. Good, good, good.
Fantastic.
Um, hey Nick, good to see you. Thanks for being here.
Eddie
We're
here.
we're just chatting about events. Does anybody else have any others on their radar that we should know about? I don't like to miss any fun. Just trying to see. We've got looks like in September the European Rotor Forum in Venice. Ooh, that'd be that'd be worth going for the tax deduction. I mean, work, business development.
Hi, Andy. I'm going to.
Hey,
Yes,
Marlena, are you gonna be at that one?
yes. It's Europe, so it's easy.
Gotta go. You gotta go, right?
They
Are you
always
gonna?
have perfect places to go. No.
Definitely. We wind up in places like New Jersey and Las Vegas. You get all the good stuff.
Yes,
Are you
but
gonna be? Are you gonna be presenting at that event or just?
yes.
Yeah.
I have a few papers. So it's more on modeling of the eVTOL. On uncertainty quantification, I do some work, connected with handling qualities. And I had in the past, for the Vertical Fly Society, there was an competition to redesign the Da Vinci air screw. And now we have a paper and they want to open a stand because it's in Italy and it's Leonardo. So they want to make a paper from Leonardo. So we
That's brilliant.
yes. So yeah, we a team of students from Delft, they won a prize, and now they're going to be included. So there are more teams also from United States, the one that won, and from Italy, from Polimi, and from TU Delft. So we wrote all together a paper.
Oh, brilliant.
Yeah, so I have quite a lot of paper, so that should cover the costs of of staying in Venice
Good.
because it's
Very good.
expensive. Venice is always expensive.
Yeah. Yeah.
And worth
Well,
it.
it looks like
And
it's
worth
worth it.
it.
Right.
Yeah, yes. So that is on the spot. For the rest, nothing. Just I'm writing proposals. The EU, they have a new a call on Horizon, and it is on innovative air mobility, on society readiness pilot. I'm going to try to participate, see if we get something for funding. So
Good.
yeah.
Fingers crossed.
Thank you. 5% chance. It's not much. It's not high.
So you're saying there's a chance.
Yes.
That's
Yes.
good. That's very good. Well, good. That'll be a great event. Let's see. We've got the vertical lift structures and survivability technical meeting coming up in October, and then air tech also in October in Germany, and and then in November the Asian Australian Rotorcraft Forum. If I need a corporate jet and more money, and then I could just bounce around to these. There's some good ones this year.
And I think paper abstracts are due for transformer to vertical flight. I think July 15th, if I'm not mistaken. So if that's going to be back in Silicon Valley this year in January, I think. But paper abstracts are due middle of this month,
Perfect.
if you want to present.
Okay, good. And that's January 27th through the 29th in San Jose. Is that right?
Yes, and it should be obviously, the home of AAM was pretty good a couple of years ago. It was good in Phoenix, but it's always better when it's in Silicon Valley.
Yeah. No, I had a great time. I had a really good time out there last time. That was a lot of fun. It's a great gang. Good. Any other events? Well, if there are no other events or um, I also like to give people, if you just jumped on the opportunity, if you haven't been here before, feel free to do an introduction, and or if you've got any new projects ongoing that you want to talk about, this is a good time too. Otherwise, I'd love to introduce our speaker. We're gonna be hearing from Dr. Thomas Jones at S-Plane. They're based in South Africa, and I actually originally learned about S-Plane from their North American partner, which is a company called Argentec. Argentec is based in New Hampshire, and they focus on uncrewed aircraft systems. So if you're in North America and you've got questions about S-Plane, you can get in touch with my friend Rita, who's on the call there, and Rita, you can drop some contact notes into the meeting chat, and then and people will be able to find you if they have questions and want to do some follow-up afterwards. So S-Plane began its vertical lift aircraft automation development in 2008, and they took on the challenge of flying a small helicopter autonomously. Since then, they've come a long way, and today S-Plane's X-Kit hardware is employed by Airbus, Indra, and Saab, among other organizations. I learned that X-Kit can be installed onto fixed wing and rotary wing aircraft, and it actually enables conversion to autonomous platforms that are then optionally piloted. So our presenter today is Dr. Thomas Jones, and he'll give us an overview of innovations within X-Kit. He'll talk about their motivations for the solutions they have developed and how these solutions are enabling their clients to create real-world systems. Dr. Jones, thank you very much for being here, and over to you.
Awesome. Thank you, Andy. Can everyone hear me clearly? Okay, great.
Indeed.
So should be able to see my presentation up in front of you as well. So firstly, thank you. I appreciate everyone inviting me to the Vertical Flight Society and to specifically this discussion. Of course, also thank you then to Andy for all the effort and organizing and coordinating this. I'm going to talk about S-Plane, of course, and our solutions, and I'm going to talk about some example applications where these solutions make all the difference to our clients. My presentation title is somewhat of a misnomer. You'll see I took the vertical bit and I put it in brackets because we do flight automation and we're pretty agnostic about whether you have wings that are rotating or stationary or fixed or whatever else it is that you are creating. But my focus will definitely be on examples on the vertical flight side, and definitely what I'm going to be showing you today lies on the vertical flight side. And Andy also shared with me the electric aircraft side of what you folks are doing. So even on the fixed wing side, that also makes sense. Okay, so let me click forward. We'll start the discussion quickly by just introducing S-Plane and the background to our so-called X-Kit. We call it our X-Kit of the equipment solutions. It's a kit of equipment, essentially. I'll tell you why we created it and what it is. Then I'll show you some of the key equipment, not all of it. I'll talk about the qualities of the equipment and so on before illustrating how these qualities enabled our various clients to perform their projects and to create system-level products. I won't keep you busy for too long so that there's some space at the end so we can have some discussion, open for questions and some open discussion. All right, so firstly, just a little bit about the background of S-Plane, expanding on what Andy has said. So we were founded in 2008, and that same year, we automated our first optionally piloted system. We took a Rotorway Exec 150 helicopter, and we put COTS equipment on board, commercial off the shelf with our software, and we created something that's no more than what I would call a demonstrator. And I said earlier to Andy as well, this is really where I see lots of folks get stuck. They create a demonstrator, and then it's tough to move from demonstration to product. And that's where we come in. We've been doing this for 17 odd years, and over time, we've created the components that folks need to get from demonstration to product. So today, we're a AS 9100 certified electronic subsystem manufacturer and supplier. And our solutions are applied to manned and unmanned aircraft and optionally piloted aircraft, and also to their ground stations. So it essentially covers quite a wide field. What you'll see is a bunch of equipment or sets of equipment that we've created, but we don't only supply these as what we call appliances. Now, I'm going to talk about appliances all of the time. When I talk about appliances, I refer to hardware and software altogether. So then it's a piece of hardware with typically S-Plane software on board, and then folks then use this as a complete solution for their specific application. But we don't only, supply our equipment in that format. What's a bit different about us is we also supply our equipment as target hardware. So folks who, for some reason, want to do their own flight control, especially in the AAM type world, where the IP, the intellectual property, is quite linked to what you see in the creation or the synthesis of this aircraft. These folks then typically like to create their own software and put their own software on board our equipment as well. So we also supply target hardware where folks can put their own software on board. And then, of course, supporting engineering services. When you do this for the first time, especially, it's quite daunting. We've done this many times. We've gone through these processes with a whole bunch of different clients, show you a bunch of different kinds of projects. So we can help folks to move through and navigate these spaces a lot faster. We are based in South Africa, which is probably the tiniest market for our equipment. We don't really sell much in our own country, so we set ourselves up from the start to supply globally and to support our clients at their facilities. So there's some travel back and forth here and there, but we do a lot of remote support and we send our people to the clients. The clients don't come to us with their aircraft. They don't have to bring their aircraft to the southern tip of Africa. There's no need for any of that. We also partner, of course, with local organizations in various countries to support us. Argentech Solutions in the US, of course, with Rito is on the call here. So we partnered with them. They assist us a lot in the US. I think Rito's probably pasted into the chat some contact detail. Please reach out to her at any point if you'd like to as well. As a subsystem supplier, our clients are systems integrators, of course. They're folks who own systems, create systems, and so on. We're the subsystems, electronic subsystems people. So we built up a diverse client base over the years. And for example, we regularly supply our solutions to at least 3 of the 5 largest aerospace companies in Europe. Our solutions apply to all manner of aircraft, manned, unmanned, ranging from 100 kilograms to tens of tons of max takeoff weight. So, like I said, we're pretty much agnostic to, what kind of aircraft, and we've created things that apply to a very wide range of aircraft. That was very intentional. So from the outset, we decided to steer also clear of the noise of the micro UAS subsystem market. So we don't deal with very small aircraft. 100 kilograms is sort of small for us. Sometimes 70 kilograms, sometimes 50. That's as far as we reach down towards smaller aircraft. We typically deal with larger aircraft. And our focus is on supplying, therefore, the more sophisticated solutions that need to adhere to the strictest standards out there, can be installed on larger aircraft, including certified aircraft, and so on. So we try to stay out of the smaller UAV world. It doesn't mean that there isn't a formality and importance in that world. It's just that there's a lot of noise in the automation systems for those kinds of systems. And then we rather step out of that. Our expertise is really in the larger aircraft. So let's talk about this X-Kit. Why did we create something like the X-Kit? The reality is that our company, S-Plane, was founded in 2008, like we said, by a bunch of control and automation specialists. And so we somewhat naively used a whole bunch of pieces of equipment, COTS equipment, for our first demonstrator, the Rotorway exec aircraft that I was talking about, 150 exec 150. But we realized very quickly that we couldn't buy what we needed to break out of that demonstration mode, model and mode. We had to move out into a world where folks could really apply and produce, apply equipment, apply our solutions, and then produce the systems that are created. What couldn't we find? We couldn't find complete modular architectures. You always had to create your own architecture for every project. And then because the aircraft were so very different, from mechanical linkages to servo mechanical linkages to electro servos to hydraulic systems, everything was different. And not just that, the interfaces to all the equipment was different every time. So we struggled to create architectures that made sense. And for every project, you had a whole lot of systems engineering trying to figure out what to do. Even though we had done it a bunch of times by then. that held us back. We couldn't quickly apply our expertise to different projects, and we needed to do things differently. We realized that we needed multifunctional and more integrated size, weight, and power optimized equipment because, of course, this is the aviation industry. And the reality is that most of the things out there, most of the equipment wasn't really made for this kind of application. So, you ended up with a whole lot of different pieces of equipment, everything qualified, everything certified, everything expensive. And the connections between them quite complex and so on. So we needed to compress into more multifunctional type equipment. And you'll see a lot of that in what I'm going to talk about today. Excuse me. You also see in what I'm going to show you today, the modern computing power that we need. So often what we found, excuse me, often what we found out there is that the computers that we needed for especially high design assurance type applications, they were not very capable. They were typically microcontrollers, not proper microprocessors. We couldn't live with that. We couldn't accept that. In today's world, we have so much processing power. Why do we always get stuck with very little processing? Multiple computers all over the aircraft, etc., trying to deal with all the different things that need to be dealt with. The basic process these days is that you get a good load of processing power in a few locations, and you hypervise. You use that processing power for everything that you need on board your aircraft. But you need to make that work together with flight critical and mission critical type behavior and activities. Together with all of this, you of course need routine access to airspace. So you need high design assurance, you need certification readiness, and you need affordabilities. Now, how do you make all of this and then also make it affordable? So that was the challenge that we got stuck with. And this isn't new. This is the challenge that I think most folks are stuck with who are in that demonstration phase. They've demonstrated, or post-demonstration phase, they've demonstrated, and now they're at a point where they need to figure out what to do next. And that's where we really come in. So we created a unique modular kit of equipment. That's what we call the X kit to address these issues. So the X kit comprises two sort of sub kits. One is a mission kit and the other one is an automation kit. And some clients need one and some clients need both. So for example, I said that we also operate in the manned aircraft space. So if folks are doing ISR activity, let's say human piloted ISR activity on a Beechcraft King Air 350, then they can use our mission chain for that to interact with all their payloads and all those sorts of things on board the aircraft. If they are into cargo transport with UAVs, then they can use our automation chain or the automation part of the kit. And if they are creating ISR UAVs, then they can do both. They can take the mission chain, they can take the automation kit, and they can put them together on board the aircraft. I'll show you examples of these. But essentially, you can see that we've created this kit that covers four sort of chains inside the mission and automation subkits. The first is we provide the airborne control equipment for both the mission and automation side. We provide the ground control equipment in ground stations and so on for both mission and automation. And then the same for communication and the same for simulation. So we cover simulation, communication, ground control, and airborne control. The equipment in the air, equipment on the ground, comms between them, and simulation that ties it all together. We created all of the products we show here. Notably, we don't create navigation sensors, for example. We don't create actuators, and we don't create radio links. These we source from third-party suppliers, but our equipment is compatible with a large variety of this third-party equipment. And of course, we have our favorites that we tend to connect to lots. I'll only talk about some of these bits of equipment so that I sort of highlight some of the important parts and interesting parts for this discussion. Most aircraft configurations, can be covered by this kit, and I'm going to talk about a bunch of examples now. Like I said, the equipment and examples of applications, and most aircraft configurations from, like I said, 100 kilograms to about tens of tons of max takeoff weight can be handled by this kind of kit. I'm going to focus on the subsystems rather than the architectures. Since our time is limited, I could have another whole talk about architectures and how one approaches these sorts of things. And I have to give you one disclaimer, and that is that to remain sensitive to the needs of our clients, I'll show only the publicly available information and publicly known projects, of course, on selected client projects. And I'll keep my remarks as generic as possible, so relating to the aircraft types rather than being specific about the specific client projects. All right, so let's start with the smaller types of aircraft. And I selected here vertical flight aircraft. So we're going to talk about an example soon and on the V200 helicopters or the UMS Skaldar. So this is our avionics solution for tactical UAS, sort of in the 100 kilogram to 500 kilogram max takeoff weight class. And again, note the themes. The themes are going to be multifunction, size, weight, and power optimized, a whole lot of computing power, and a wide range of applications. And so you can quickly apply to many, many different kinds of systems. So here you have one enclosure, and inside that one enclosure, you have redundant computing, and that's proper computing, and we'll talk about that in a moment. You have an enormous amount of software configurable I/O. So you connect this unit to many, and all subsystems essentially of this in this aircraft. It has network switching capability on board for connecting up to proper communication networks. It has internal redundant radios, and that includes MIMO mesh radios, the software-defined mesh radios, multi-input, multi-output, multi-antenna type systems. It has the best sensors that you can pop into a box this size, including really proper multi-antenna differential GPS, and again, redundant. And then for different clients, we have some the different build variants. So there are many build variants of this that are out there. But importantly, I said earlier, proper computing power. This is something we've always struggled with, affordable, proper computing power. So we created it ourselves. Inside here, you have multi-core type processors, so the kinds of things that you'll see in laptops. So not the high-end best laptops out there, but basic laptop computer type processing capability. You get rid of the very intensive operating systems, and you replace it with a certified hypervisor capable operating system, so that what that means is you can run high design assurance software and lower design assurance level software on the same computer and certifiably keep all of this apart and therefore safe. So you can have your flight control code and design assurance level A, B, C if you want that, A, B, or C, and you can have design assurance level D or E mission code that sits somewhere on the same processor, and the operating system uses the processor optimally to do all of this calculation and work and background computation, but keeps them sufficiently apart, splits them amongst the cores on the processors, splits them amongst the different computers that are available, etc. So this allows you to do, like I said, I keep using the word proper processing, so that you can apply these sorts of things to interesting products and projects out there without compromising on the processing power available, and giving you the ability to have a single enclosure of processing capability, or maybe a second one next to it for further redundancy. Right. I'm not going to get into all the applications and certification side to it, but it's all the correct kind of standards that you need to be able to apply this unit to different kinds of aircraft, and the certified space as well. And again, it's a complete appliance, but then also as something that you can use for target hardware, as target hardware. So let's talk about an example. This is an application with UMS Skaldar's V200. Now, the V200 helicopters, they are in service, and you can go look on the internet. They advertise all of this with, I believe, the German, Dutch, Belgian, Spanish, Canadian, etc. armed forces. So they're quite prolific out there. Lots of folks use them. It's a product that's been in production for many years. And they use the NXFCU as their primary flight control unit on board these aircraft, and then also as their mission system computer on board the aircraft. So let's have a look at video quickly. I'm going to take a chance. Andy and I tested it earlier. If you have any trouble with the video, just let me know. I'm just going to voice over. There's no sound on the video. I took it away so I can voice over. But the point here is this is firstly a video from 2021, so it's already a while back, but it illustrates very nicely what this V200 does. It operates from vessels, essentially. So you have one avionics unit for all of your functions. You have comprehensive flight automation, including automated takeoff and landing from ships. You have all your onboard sensors and everything that supports that. You have your IO concentration, so you can connect up to all of your subsystems, not just your flight critical subsystems, but also your mission interfaces. So you connect up to your electro-optic sensors, to your radar, signal intelligence, transponders, all these sorts of things, all in one redundant avionics package. Then your comm solution, of course, is also included in this, so you don't need separate communications devices. And for this kind of application, this is a naval application. These are also qualified for naval use. So these units handle nasty salt spray and all those sorts of things and are properly qualified against DO 160G to be the environmental standard to be able to be used in this kind of environment. All right. So this is just an example of where you have this unit and this NXXU, and it is applied or employed by a product that is in circulation use out there, and how it enables such a product to, such a system to operate properly. All right. So let's step one step up. So let's talk about larger types of aircraft. So, so if you take all the navigation sensors out, the radios out, and the avionics out of the avionics, because you can't have all of those things in if you want to increase design assurance levels. So start controlling larger aircraft. You add redundant power distribution units inside. You beef up the environmental qualification even more, a wider temperature and vibration ranges, and all these sorts of things. And you add more IO and more diversity in IO. I think there are 116 ports on a unit like this, so you can pretty much interface with anything on board an aircraft. And then you add native support for all sorts of very formal redundancy, like and redundancy architectures, safety architectures, common self-checking pairs, with native dual and triple modular redundancy support. And what that basically means is if you fly in a Boeing 777 or Airbus A380, that is the kind of architecture. They will fly DMRs and TMRs. So the way that the electronics are put together in their architectures and so on. So you can tell that this can be used for many applications. It can range from mail UAVs, hail UAVs, all the way through to AAM type applications. And I'll show you what these sorts of things look like. Again, same as before, you can put your own software on board, or you can use S-Plane's software on board these things. We created these things as products for ourselves. So we are clients of our own products, and we also provide these products to other folks who need to be able to use them. So we're clients for our own target hardware. On the ground side, you have an equivalent computer. I'm not going to get into too much detail about this, but essentially, folks often forget that on the ground side, you also have safety critical functions, especially on unmanned systems. So this is where our remote piloting unit comes in. We have this computer called an audio-visual unit that we created with all the right, I/O to be able to connect up to certified touchscreen displays on the ground, all your primary flight control interfaces, hard push buttons and I/O and all these sorts of things, etc. And that's what this RPU is for. So with an RPU, remote piloting unit on the ground, and with an X-cube on the aircraft side, these things connect to each other, and then they facilitate automation. So some examples. So the X-cube and the RPU, they're, for example, used by Airbus on the Airbus Up Next on the Extra Performance Wing project. I'm not going to discuss the details of the project. You can go and see online. There are lots of interesting things going on there. And you can have a look on the internet for more information, including flight tests and all sorts of other things that they're up to. But you can imagine on this type of aircraft, this is a 10.5-ton Citation 7 jet. you need to prove that you can operate safely. And you need to be able to handle safe and complex computing, much more complex computing than smaller types of units. And you interact with so many more different kinds of subsystems in very formal ways. So you need enormous interface, a variety of interfaces, many interfaces, so that you can reach all of these different kinds of subsystems to be able to handle, to make these aircraft. Then on the AAM side, you might know of Ascendance Flight Technologies. They use the X-Cube as their flight computer, and essentially their fly-by-wire flight computer for their ATEA hybrid power AAM aircraft. They are based in Toulouse, in France. So AAM aircraft mostly require fly-by-wire. I guess you folks also know this. I mean, due to the nature of their propulsion and actuation systems, they are not direct linkages. It's complex control that needs to be performed. Therefore, always need fly-by-wire control. They also require more complex power distribution, more computational power, and the ability to control high-powered electric propulsion systems. And all of this has to be at a high design assurance level, because essentially these computers sit between pilots flying the aircraft and the actual aircraft behaving a certain way. That's typical fly-by-wire. So the X-Cube is a great enabling solution for this. And this is a great example where we don't provide the flight software, because the clients are creating their aircraft. This is their system, and they are the experts on what their fly-by-wire system needs to look like. So they create the software for this, and they put all their flight software on board the X-Cube. So this is a great example of where the X-Cube is used as target hardware, not running typical S-plane software. All right. Then on the mission side, I talked about the mission side of the kit. You also need to be able to connect up to all these different payloads out there on your aircraft and optimally use them. And you need even more capable computing power, including GPUs, graphics processor type things, for modern AI computing and signal and image processing and so on. And that's what these units are for. We call them XADTs. They're essentially mission computers for manned and unmanned systems. In this sort of case, you have even more functions combined in one enclosure at the cost or the pricing of a little more than singular subsystems. That's what was really important for us to create these sorts of things. So essentially, you have high-performance computing, you have software configurable I/O concentration, data storage, network switching, STI, video encoding, all of these things in one singular solution to be your solution that you put on board your aircraft to connect up to all your payloads. And again, as an appliance or as target hardware for folks who need to do that. So that's the hardware that you typically put on board the aircraft on the mission side of the kit. And then you need software. So you need to have HMI software. In some way, you need to be able to connect up to control your ISR sensors and all these sorts of things. And you also need to be able to do command and control and connect up to your X-Cube, for example, on board your aircraft to send it new missions and all these sorts of things. So Paragon is our software. It's called Paragon. It comes in 3 flavors: Paragon ISR for mission systems, Paragon C2 for command and control, and FTE for flight test engineering stations. So we also create flight test engineering stations with Paragon on board. The software is essentially a very highly configurable 3D moving map type system where at startup, the software reads a bunch of configuration files, and then it figures out what it needs to be for you. So what that means is that you end up changing the I/O, so essentially the ICD of the interface control of the software, its database, its widgets on the screen, its layout, all these sorts of things. All of those things are adapted at startup. So the software reads configuration files and quickly becomes what you want it to be. And this is important when I said from the X-Kit side, we need to be able to quickly adapt to different aircraft and different systems. So we don't have to recreate software. We just quickly configure that software to use in different applications. So very importantly, it connects up to a wide variety of things like radar and electro-optics and everything else that you need to, and connects all those things and uses them optimally. But it also on the C2 side handles things like mission synthesis, creating your missions, editing them, uploading and downloading them, and so on as well. And it enables multi-aircraft control and seamless handover of aircraft between your HMI operators that can either be in the air or on the ground or in different ground stations. So you have this capability to hand your aircraft over, both for command and control purposes and ISR control between different stations, either in the air or on the ground. So let me show you examples again of this. So for Indra, their Targus, Indra is the largest defense manufacturer in Spain. Their largest, or their Targus optionally piloted system based on a Tecna P2006T twin-engine aircraft. There we use the entire X-kit, so that's both the X-Cube side and also the ADT side, the Airborne Data Terminal side. And there the ADT, or the mission computer, connects up to the radar and the electro-optical systems, AIS, and all those sorts of things. And in this case, the X-ADT is on the aircraft in a basic format. So the X-ADT is on the aircraft, and the Paragon is on the aircraft in a very basic format, but the primary software or control station is essentially on the ground. So when a pilot gets out of the cockpit, this is an optionally piloted system. The automation system on board the aircraft takes control. The mission payload system, that's the X-ADT, takes control. But the control is handled from the ground station. The HMI interface is on the ground station, so they're on the ground. It's the typical male UAS type way of doing things. So that's one way to support these kinds of projects. Then for completely manned type systems, we have clients who do King Air 350s. So in this case, integrated with, for example, Preciser ISR, Insult Preciser radar, Insult Argos 2 electro-optical systems, and so on. So the Paragon consoles are inside the aircraft together with the mission computers, with the X-ADTs. And then inside the aircraft, there are various configurations of Paragon that are run. So some folks have tablets in the cabin, so they walk around the cabin with tablets so they can have situational awareness. Observers for on missions and so on, they have tablets that they can use to see what the payloads are seeing and so on. And then also there's a display in the cockpit, so you typically have a display in the cockpit so that you have situational awareness in the cockpit. And then you have HMI control stations, and the HMI control stations then serve as the primary control for all the payloads on board the aircraft, with the human pilots flying the aircraft. And on top of that, it connects to HMI operators in a ground station. So on the ground station side, you then have HMI operators who then can control the payloads also from the ground. So you have the option to do control from the sky, but also over links to the ground from the ground station. All right. So you get this combination of UAV and typical manned type operation. The same for smaller versions, more cost-effective ones like the CNG Helix ISR system. It's a Stemmer ASP-15 aircraft out of Germany. So this is one of the incarnations of that with the Insult Argos 2 electro-optical system. So there you have a ground station only, very basic setup in the cockpit for situational awareness, but then a proper ADT on board to record and do GMTI processing, ground moving target indication processing, and all the fun things that you need to do with high fidelity video on board the aircraft. All right. I'm going to sort of fade out now with a few last things, but I think then there are two more components to show that I think are quite interesting for this discussion. And the first is that most of these projects, especially on the automation side, require hardware in the loop simulation. So we provide these XMELS units and integration testing stations. They essentially connect up to aircraft and make them think that they are flying when they're not flying. Airbus and others call these Ironbirds, for example. So it's a system-wide hardware in the loop simulation with failure modes included. It's not just flight dynamics and flight control. So environmental models and dynamics and engine control units and FADEX and fuel management and power management and everything else handled in simulation, plus the failure modes. and then you apply it to your development activity, to your integration, verification, validation, your post-maintenance V&V, your training, your certification, all these sorts of things. These days, you cannot put all of this equipment together without proper hardware-in-the-loop simulation. You use them at test benches, all these sorts of things. And then the last thing I'll show you is the Tracker Plus, and this is on the communication side, because we also need reliable, high bandwidth, long range comms. So of course we support SATCOM and beyond line of sight and line of sight communication. And we manufacture our own antenna trackers for this purpose. So these are different in that they internally accommodate very high power links. So they can dissipate up to 800 watts of heat. So links aren't very energy efficient. They typically maybe 20%, 25% energy efficient. So they create a lot of heat. So large links can be put inside here, and they're temperature controlled on the inside. It's a completely sealed unit, and clients can choose to put links inside that are not sealed because the unit itself is sealed and the unit itself is temperature controlled. So that made all the difference for us and for our clients, because you often end up in situations where you're stuck. Where you don't end up being able to, repackage your links because they need to handle environmental, environments that they just can't function properly inside. All right. So, and again, proper DO 380 environmental certification and qualification for these sorts of things. And that's sort of my message. I think that's what I wanted to quickly show. And that is that it's essentially a kit of equipment, making us take the leap from being in a demo world all the way through to folks who are doing either very high-end experimental activity or create products. So making that leap from one point to the other, I think lots of people are in that space. And we've been doing this for 17 years, so we had to create the equipment that folks need to be able to do this. And I think it can help a lot of folks out there to know about this and to be able to use these sorts of things. So thank you from my side. I appreciate it. Back over to you, Andy.
Dr. Jones, that is absolutely amazing. I'm kind of blown away by how comprehensive your set of tools is. It's if you had any one of these solutions, I would be impressed. But you have this whole umbrella of products that work really well together. I think it's like a gift. It's going to be a gift for a lot of airframers to understand that this is available and that they can just partner with you and start to integrate these things tomorrow and take advantage of almost 2 decades of development work. So thank you for sharing that.
Thanks.
Let's open it up to questions. Nick, I see your hand up. Fire away.
Yeah, I want to congratulate you on the idea of having a standard set of available capabilities so that folks don't have to develop it on their own nickel, which I think is just great. So it brings up a couple of questions. Number one, and I realize it's difficult, can you state what you think is a ballpark price for the computational boxes themselves, which is always a big issue for OEMs in terms of keeping the cost down?
I'm sure that varies quite a bit depending on the solutions. Your solutions must be all over the place in terms of what your customers want to do.
Yes, exactly. So it's actually hugely wide. So if you just look at something very specific, just like a flight control type unit or avionics unit that goes inside an aircraft, then they range anywhere from sort of the $20,000, $30,000 mark up to about the $130,000 mark for the TMR capable or triple redundant units with all of the bells and whistles inside them on the X side. So it really depends on what what the application is for the client, and they come in a bunch of different build variants. So what we always try to do is we try to minimize the build variant to give the client only what they need. Otherwise, you also end up with something that is too expensive and has too many functions. For example, things that you don't necessarily need. So you try to cut down, and that's what's important for us. Is we try to create these units that have safe build variants, so that you can basically get what you need and no more than that.
Good answer. Thank you very much.
I feel like scope creep would be a big problem for me if I was to work with you, because I would keep saying, well, I want that too, but what about that? Could we add that? Let's roll it all in there. I'm sure you have clients that just say, well, just give me everything.
Exactly.
Todd, I see your hand up. Fire away.
Yeah, I was wondering, do you have, I see a pretty good sized aircraft here. Do you have like a very small system with less capabilities for small UAVs?
Todd, we in our world, I think the smallest that we put together, especially on the automation side, is our NX FCUs. And they're typically targeted at aircraft around the 100-kilogram max takeoff weight, so 220 pounds and up. So we do have clients who use them for high-value systems, especially if they have high-value payloads on board, that use them for aircraft around the 50, 60, 70-kilogram mark. But mostly they're used sort of from the 100-kilogram to 20 pounds up. That's sort of our world. So it's sort of the formal development type world.
Excellent. What other questions are out there? I've got one, but I want to hear somebody smart ask one. We've just got a couple minutes left, about 3 minutes. Dr. Jones, I was going to ask what, and I know this is like price, it's an answer that depends, but what have your integration timelines looked like for your work with customers? And I get this has got to be all over the place depending on how shallow or deep they want to go with your solution set, but is it a year? Is it 2 years?
Yes, so we can talk through that. I think what's important is that in our engagement with clients, it's sort of a careful and well-structured process. I think that's the most important part, is to have something that's well-structured. We run through essentially 2 to 3 phases with our clients. One will be this initial system design side with clients. The other would be the synthesis of the system, and then synthesis and/or certification as the third step. So inside these, I can break it up a little bit more. Typically, we engage with clients for about 2 to 3 months to help them to sort out their architectures, their systems architectures, help them to sort out their system requirement specifications, their functional specifications. And we then, after the 2 to 3 months, essentially have what we need to understand together with the client what they want to actually create. That's always very important. What do you really want to create? What are the real specifications of the thing that's going to come out the other end? What do you really want to do? So it's 2 to 3 months of that. And then we typically take about 7 months or so, 7 to 10 months to do the synthesis part, to put most of the equipment together and make a little bit of some changes, configuration changes, customizations that the client needs. And here it can be different depending on whether the client needs a lot of customization or whether they're just using our hardware and putting their own software on board. And then we typically go through integration phases of maybe 2 or 3 months, and then flight testing for anything between 3 or 4 months or to 6 to 8 months, depending again on the complexity of the system. So if you look at the overall picture, we're talking about roughly 16 to 24 months is typically a process that we would go through. And then if the clients want to go through certification, that either happens in parallel or after, depending on how they structure this and whether they're first creating a demonstration system and so on. So that's essentially, it will give you a good idea of what it looks like. And we normally try to be flying within about a year. So it takes normally about a year for the aircraft to be airborne with our equipment on board for flight testing to start.
Brilliant. It's a huge time saver compared to trying to do this. This is obviously, a decade plus for an organization to do it on their own. So they get a huge leap forward in working with you. We're at time, but Linda, I see your hands up. We got time for, let's do one quick question before we say goodbye today.
I apologize for the last questions here. So in the industry, there's a Honeywell on the flight control. There's also Garmin in the flight control. And for the UAV, there's Pixhawk. What's the landscape in this product you provided here in terms of the niche market?
Yes, so earlier in my presentation, I think I touched on some of that. I think our world is above the smaller kinds of UAVs. So we typically don't operate in the noise floor below maybe 100 or 70 kilograms or so of max takeoff weight. We typically operate larger aircraft. So our typical aircraft, our average aircraft is maybe between 1 and 2 tons of max takeoff weight that we deal with, and sometimes larger, 10 tons, 10.5 tons, whatever the case might be. So we're in the slightly more formal world with larger types of aircraft, not things like Pixhawks and these sorts of things. And we don't normally compete in that market or work together in that kind of market. We're in a very different kind of space in terms of the kinds of equipment we create.
Understood. I probably should just wrap up my question. My comment earlier is on high end, there's Honeywell flight control. That's a whole package.
Yes.
And also there's the Garmin's flight control, which is quite matured. On the lower end, there's Pixhawk. So where do you fit? Just a quick.
Yes, very quickly. So folks like Honeywell, they'll be talking flight control. So flight control is one component of the X kit. So that's one component of it. And they are typically in the market of creating flight controllers specifically for certain kinds of aircraft. So they will create flight controllers, say, for flight control units for, say, commercial airliners and these sorts of things. They are typically also much more expensive. So that becomes, it's a more expensive unit made for even larger aircraft. So we fit in between, we fit underneath that in terms of cost and pricing. Things like the Garmin aircraft units, for example, they are not full flight envelope controllers. Remember also, this is important if you look at flight control, even with Honeywell and with Garmin, we can't live with basic autopilots that kick out when you reach certain levels of turbulence or that don't meet the complete flight envelope of the aircraft. In our world, you need to be able to take the pilot out of the cockpit completely, which means that your flight units are what we call full authority autopilots, which means that they are made for an environment where you can control the aircraft to its full extent of flight envelope. They don't have limitations within the flight envelope of the aircraft, like a typical aircraft autopilot would have when it's operated by humans on board.
Okay. Thank you for the answering here. Thank you.
Thank you.
Outstanding. Dr. Jones, this was wonderful. I really enjoyed this presentation. I think our members that were here did as well. And also we'll shoot you a copy of the link to the recording, and so you'll be able to share with your other constituents. Thank you so much for being here.
Much appreciated. Thank you, Andy. Thank you, everyone.